Hey folks, welcome to our GDAL tutorial today. Let's just go ahead and jump right in to get started with GDAL. We're going to do this using Python. So I have a Jupyter notebook open here in Visual Studio Code. You can use this just in the terminal. You can write a script however you want to do it, but I'm going to be doing it in Visual Studio Code or with Jupyter Notebook just so I can demonstrate things a little more easily. Let's just go ahead and get started with the imports. The first thing you're going to have to do, though, is you're going to have to make sure you have GDAL installed, the package installed for your Python distribution. And I have some videos on how to do that, and I'll try to remember to link those below. I have a video for how to do it with pip and a video for how to do it with Anaconda. It's not that difficult, but there are some nuances to installing GDAL, so make sure you get it installed correctly. Let's go ahead and start with some imports. So we're going to do from OSGeo import GDAL. Now, it's possible, depending on the GDAL version and how it was installed, you might just do import GDAL if you get problems, okay? I'm going to import numpy as np, and I'm going to import matplotlib.pyplot as plt. And let's go ahead and run that. And then I need to specify a file name for a raster. So the file name for the raster I'm just going to copy one over here. It's a raster I have, and I'll show you what it looks like. It's an elevation raster, a digital elevation model. I've got it pulled up here in QGIS. This is what it looks like. All right, let's head back over here. So I'm just going to run that code to get that file name put in there. Now, let's say you want to open this raster. So we just want to open a GDAL data set. It's very easy to do. We'll do a data set, our DS, GDAL data set equals GDAL.open. We're going to open the file name. And now let's print the type just so that we can make sure things work properly. And I'm going to hit Shift Enter to run that. And you can see that our data source type is a class, and it's a GDAL data set, which is what it should be. All right, so now we want to get some information, some properties, some metadata from this raster. So let's go ahead and do that. So there's a lot of things we can get here. I'm going to print these out so we can see what they are. So let's get a projection. That's something we often want to get. So we can do that with ds.getProjection. Okay, and let's just print out a few things. So let's print columns, which is also the X size. We can get that with ds.raster size. And we're going to print also the rows, which is the Y size. And we can do that with ds.raster Y size. And then let's print out the band count. So we'll do bands, and that's ds.raster count. Okay, so we have all this metadata. Let's go ahead and hit Shift Enter, and we can print this out. So you can see our projection here. Net 83 is the geographic coordinate system. North American data 1983. We can scroll over here. This EPSG code, the last one here, defines that projection. So that's kind of our last authority. This is just the NAD 83 projection. We'll use that again later. 3612 columns and rows, and there's one band. Okay, so that gives us some good information. So now the next thing we want to get is the geotransform. So this kind of tells us some of this metadata. It doesn't tell us exactly where in space our raster is located. We get that from the geotransform. So let me print this out here for you. We're going to ds.getGeotransform. Let's hit Shift Enter. And you can see here, it's printed out a tuple with 6 values in it. I'm going to zoom in a little bit so you can make sure you can read this real well. So this is our top left X coordinate, okay? So negative 115 degrees. This is our X pixel resolution. going to be pixel width in degrees. Now this is going to be in the coordinates of our projection or coordinate reference system, which I don't know. Yeah, so it says unit degree right there. Okay, so that's how we know what these units are. Okay, then we have 44. That's the top, or that's the top coordinate. So our top y coordinate. This is latitude. This is longitude. So with this one and this one, we have our top left corner. This is just a rotation, and this is a skew rotation. Those are almost always 0. I wouldn't even worry about making them something else. I've never changed those to something else. Okay, and this is our pixel height, or our top to bottom pixel resolution. It's going to be negative for north-up images. Okay, and you can see that it's the same, just negative, as the east-west resolution. All right. So that geotransform has a lot of important information, and we're going to get into using that a little more later. Okay, and I will mention that all this code is going to be on the website, so you can copy and paste. It's going to have explanations about everything in case you forget this stuff. Now, we haven't actually read any raster data yet, and we want to do that. We actually want to get the data for the raster. So let's do that. So let's get our data array. It's going to be a numpy array. We'll do ds.getRasterBand. We want to get raster band 1. There's only one band. We're going to read as array. Okay, now notice Python indexing usually starts at 0. Here we're getting raster band 1, which is the first raster band. So just a little nuance there. Okay, and then let's print out our data array.shape. And that will just tell us what the shape of that array is. So we can see that we've actually loaded something in. And then we'll display it here in a minute. So let's hit Shift Enter. And you can see that we have the number of rows and number of columns as we have here. So it appears that it's the right shape. Okay. Now let's go ahead and plot this so you can see what the raster looks like. Pretty easy to do. We'll do plot.figure. I'm going to make the figure size 10 by 10. And then PLT, we're going to use IMShow to show this 2D array. So data array. And then we'll put a color bar on there. Color bar. Okay, so I'll hit Shift Enter. It's going to make a matplotlib plot. And so you can see there's what our raster looks like. If I go back to QGIS, different color bar, but you can see that they do indeed match up pretty closely. Okay, so there's our raster. That's how you can easily display a raster with Python. We're going to do another video on some more of the intricacies of doing this. You notice that our coordinates aren't correct, but the data show up correctly. All right. Now, this raster doesn't have any no data values in it, but some of the rasters you work with might have no data values, and we can get those from the raster band. So let's go ahead and do that. So let's do ndv is our no data value, and do ds.getRasterBand1.get no data value. Okay, and we can print no data and ndv, and let's hit Shift Enter, and you can see here is our no data value. Okay, so we have that saved for later use if we need it. We can also set no data values. I'm not actually going to set the no data value here. Well, actually, we could just do it. We'll just do ds.getRasterBand1.set no data value, and we'll just set it back to the ndv. That's fine. And so if we run that, we'll probably get a 0 here that tells us it was successful. That 0 just means there were no errors and no problems returned when we ran this code. All right. Now that we've done this, if we're done using our raster, we need to properly close a raster data set. And the way we do that is we just do ds equals none. And now our raster is properly closed. If I type, let's just go here and type let's just type ds down here now. And if we run that, nothing happens, right? We don't have anything. DS is just none now. There's no raster data set assigned to it. Okay, so that's the basics of reading a raster in GDAL and closing that raster. Really simple to do. Let's go on now and talk about and demonstrate how to create and write rasters with GDAL. This is a little more complicated, but it's not very hard still. Now, the first thing you need to understand is when working with GDAL and creating rasters, everything works from a driver. So a driver is related to a file type, and it basically gives us everything we need to interact and create and write with files, with raster files. So I'm going to create a GeoTIFF driver. So we'll call this driver GTIFF, and it equals GDAL get driver by name and GTIFF. Now, GDAL has a ton of different raster drivers for different formats. I've linked to those on the website post if you need to go find out which one works for the particular format you're using. Now, we can do type driver GTIFF, and this will just tell us what type that is. So if we hit Shift Enter, you can see that it's OSG or GDAL driver. Okay. Now let's go ahead and just copy an existing data set. This is quite easy to do. We're going to reopen the first data set we created, which is ds or equals GDAL dot open the file name. So we close this one, so we have to reopen it. And then let's make a new file, fn copy equals, let's see if I saw that file name copied. I do. We're just going to do this. We're going to rename this over here to just GDAL copy, so then I'll just copy this. And then we're going to do ds copy. And this is where we're going to create the new raster data set. We use our driver GTIFF, create copy, and we're going to give it the file name, fn copy, and we're going to give the data set, GDAL data set, to copy. All right. Now let's go ahead and do ds copy. Okay, and let's hit Shift Enter, and that will run. You can see that this is a GDAL data set. Okay. Now, we're not going to be done with this yet. I'm going to demonstrate something when we're done here, but right now let's just keep this as it is. So what you might want to do is, it doesn't help us to have two copies of the same raster. Maybe you want to read the data from the original raster, modify it, write it back to the copied raster, and then save it. So let's go ahead and do that. And in this case, we're going to just apply a multiplication factor to it. So let's get data array equals ds get raster band 1. So we're getting the data from the original raster, read as array. Now, right now, the original raster data and the copied raster data are the same. Let's get data not a number. So we're just going to basically make any no data value here not a number. np.where data array equals the no data value. We created this already. It's going to be np_nan. Otherwise, it's going to have the same value as data array. All right. And then let's get the minimum value. So data min equals numpy.min data min. And then we're going to now do data stretch. This will apply the multiplication. Equals np.where data array equals no data value keep it no data value, and otherwise we want to do data array minus data min, and then multiply that by 1.5. So this will apply, and this will apply a stretch to our data. The result's going to look the same if we plot it, but the values are going to be stretched differently. Okay. All right, so basically we just created this data man so we could get the minimum value really easily. Otherwise, if there was no data value, we'd get the no data value and it would mess up this calculation here. Now, we're going to write this to our copy array. So ds.copy equals get raster band 1 dot write array data stretch. And then we're going to close the data set. Okay, so that will give us a new data set. I'm going to run this. Then we'll go to QGIS. We'll pull in our new data and we'll check and show that it's different than our old data. So let's hit Shift Enter, and hopefully we don't get any errors, which we haven't. Let's go to QGIS. I'm going to go to my browser. I'm going to pull in GDAL copy. It looks the same if I use my raster value tool here. You can see, oh, GDAL copy just has no data in there. Something wrong has happened. So let's go back and see if we can figure out what that is. Okay, so I think the problem might be that I already have this file from testing this out before I did this video. And when I open it in the notebook, then it can't write to it because it's already open. So let's just create a brand new file and then we'll try it. We won't print this out this time. So let's see what happens here if I just change this file name. Hopefully there's a problem and that means the code should work for you. So let's hit Shift Enter on this code and we'll control under that. And now let's go check out QGIS. And if we go to browser, copy to, let's add that in. There you go. Now you can see we have some data there, and you can see that it's stretched differently than our other data, right? The lows are darker because we have a higher stretch. You can see that our values indeed are different if you look over here on the side, okay? And so when you run it the first time, it should work for you without any trouble. Mine was just related to me already having the file on my machine. Okay, so that's how you can write data to a new raster. You'll see that when we do this in QGIS, those rasters line up exactly because we copied over the projection, the geotransform information, all that stuff, and so they line up seamlessly on top of each other with the same cell resolution. All right, now there are going to be instances where you need to create a completely new raster from scratch. So let's go ahead and do that. So let's make a new file name. It's going to be fncreate equals, see if I still have a file saved, yep, and we'll call this GDAL create. I deleted this file, so we shouldn't run into the same problem we did before. So ds create equals, we're going to use our driver again to create a data set. Driver gtiff, we're just going to use create. Okay, and we're going to create it at the file path fncreate. We're going to make a very small raster. We're going to give it an X size of 10, so 10 columns, Y size equals 10, 10 rows, bands equals 1, and the E type, this is the data type, equals gdal.gdt. And you can see all these different data types here. We can give it floats, different bits of integers. We're going to go with byte. So that means we're going to have values between 0 and 255. And this will create our new raster. So let's go ahead and run this. So Shift Enter, that'll run it and create our new raster. Now with this raster, we need to give it some spatial reference information. So let's start out, we'll go from OSGeo import OSR. This is going to be a spatial reference, so we're going to have to create a spatial reference and assign it to our raster. So let's get a spatial reference system SRS equals OSR dot spatial reference. Okay, we're going to do SRS dot import from EPSG, and now I'm going to give it 4326. This is the EPSG code for the basic WGS84 geographic coordinate reference system. Okay, so I'm going to go DS create dot set projection. Now we can't just give it SRS, we have to give it SRS dot export to WKT. All right. The reason we do this is the projection for the data set is in well-known text, WKT, and so if we take our spatial reference and export to WKT, things work out seamlessly. All right. And now we can do, we'll just do ds create dot get projection, and this will print out that projection information so that we can make sure that things look correct. So let's go ahead and hit Shift Enter. Oh, and we have a problem. Let me see. Oh, that's because I forgot to put parentheses there. So let's run that again. Okay, you can see here that it's printed that out, and our EPSG here is 4326, as it should be. All right. Now we also need to set a geotransform. So let's do that. And this just needs to be a list object of some kind. It can be a tuple, it can be a list, doesn't matter. I'll do a list. So we set the projection, but we haven't set where this raster is in space. So let's just give it some coordinates. We'll give it an x coordinate, so top left x of 110. Give it a pixel width of 1 degree. No rotation there. We'll give it a latitude of 45 and no rotation or skew there. And we'll give it a pixel height of 1 degree also. Now we can do ds create dot set geotransform got create. So we're passing in that geotransform we just created. And now we can do ds create dot get geotransform just to check our work, and that will print that out. So let's go ahead and run that. You can see the geotransform is just as we set it there. All right, now we need to create some data to write to this raster. So let's do data create. We're going to create an array of zeros. It needs to be the same size as our raster, so 10 rows, 10 columns. Let's go ahead and set some values. Okay, so we're going to leave the outer values as 0, and we're going to set everything inside of that to be 1. And we're going to copy this and just adjust things. And now we're going to take another inner portion. So we'll have a section of 2 pixels that are a value of 1, and then we'll set the rest to be a value of 2. That's where that copied. And then we're going to set the center pixels to be a value of 3. Okay, I'm not going to go through and explain all this indexing. You can go look this up if you feel the need or study that out a little bit. It's not too difficult to figure out. Okay, then let's go ds create. Let me scroll down so you can see that. We're going to write this band to our array, so get raster band 1 dot write array data create. And now we need to set a no data value, so ds create dot get raster band 1 dot set no data value. And we're going to set 0, and ds create equals none. That will properly close our raster. So let's go ahead and run this, and we should be able to open it in QGIS and see our results. I'm going to go ahead and run that. Let's go over to QGIS. Let's go into our browser. Here's our create. Let's add it in. Uh-oh, it's not a valid data source. Okay, so something went wrong here, and it could be because working with a notebook, things get messed up sometimes. So let me just see if I can delete this and make sure it works. All right, let's just go ahead and change the file name here. GDAL create 2. And so we'll do this again just to to make sure this all works out. Shift enter, shift enter, shift enter. We'll run that. Go back to QGIS, grab GDAL create 2, drag it in. Okay, that's fine. It's asking us for a conversion because this raster is located. It has a different coordinate reference system than our current project. So let's zoom here. Okay, so you can see that there's our raster in relation to our other one. We can go into our browser. We can add an OpenStreetMap so we can see where this is. We'll apply the same conversion, drag that down to the bottom, and you can see that that appears where it should as far as the coordinates. You know, that coordinate is 45 and 110 if we zoom in on it, you know. So everything is where it should be. All right. Now see that coordinate's a little bit off from what it should be, and that's because we have this different projection of this conversion going on. But if we open up our GDAL create 2 information here, you can see that everything lines up as it should with the extent. All right, folks, that's your intro to GDAL with Python. Hope you found this useful. Like I said, the code's going to be on the website so you can copy and paste. And just realize when you're working with a notebook, you sometimes run into problems with files not closing or saying they're open in Python. So you might have to be a little creative working with notebook, but it's just the easiest way to display things. I hope that's helpful. Have a great day.